So now let's take a look at encryption over ZMQ. The reason we installed ZeroMQ with sodium is because ZMQ uses libsodium for curve encryption. And since we did that, we can now try and encrypt our traffic back and forth. In one of the previous examples, if you noticed, we looked at the traffic in Wireshark, and you could see that the traffic was being sent in the clear. So what we will do now is implement the simplest example we can of curve encryption, just as a starting point. So this example is not meant as the best example out there, but it is the most minimal example I could come up with that demonstrates curve encryption in ZeroMQ. What we'll have is, just as before, we'll have a program right there, a request and reply socket. The request socket sends an integer, and the reply socket sends back the square of that number. There's nothing special about this program. We've seen this multiple times before. But if you open up Wireshark, you'll see that the numbers that are being sent back and forth are in the clear. So you can see the data right there. We are going to try and encrypt this traffic. So we have two sides to this application. We have the client side and we have the server side. The first thing we're going to do is generate a curve key pair, server side. It's going to consist of a secret key and a public key. Next, we will create a server thread that serves up that public key to any peer that matches up with the password. And the pass will be, let's say, pass 123. We'll do a comparison, a string comparison, and if it is successful, we'll send back the server-side public key. Next, we'll take the server-side public key that we received in the client, and we'll generate a client key pair. Okay. And once we do that, the traffic will be encrypted. So this example is a straight up vanilla example that we're going to start off from. Nothing special about it. We've seen this a million times. The first thing we are going to do is, in the server-side application, we'll call a ZMQ curve key pair. And ZMQ curve key pair will generate a secret key and a public key. ZMQ curve key pair returns a condition, success or failure. We'll check this for success or failure, and 1 indicates failure. If curve key pair generation is a failure, we'll exit the program. In a real program, you obviously don't want to shut down your server, public key server, so you'll have some alternative logic, but just as a demonstration here, just to keep things simple, we will exit this. Next, we'll create a thread that serves up this public key. Let's call it the P key server. And now let's write the public key server. This will run on socket 5555, and it'll be a plain old reply socket. Again, nothing special about this thread either. It's simply responding to correct passwords with a public key string. That is all it's doing. So we receive the password, compare it against pass123. If it's successful, return the public key. So that implementation is done of the reply server. Now on the client side, we'll write a function that goes and grabs that public key. Public key server is on 5555. We send the password pass123. And expect a reply back. Now there's a bug in that program there, because if your password is incorrect, you'll just end up hanging on the receive socket. So you're going to have to come up with some logic handling that branch there. Close the socket, close the context, and that is your request function for the public key on the client side. Now we have to set some options on the server side. We have to tell it that we need to set up a curve server. Hand it the secret key. On the client side, we tell it to grab the public key from the server. And then do the curve key pair generation. set the client side public key and the client side secret key. And we should be good. Now let's run the program. And do a packet analysis in Wireshark. And everything is encrypted. So this is your bare bones curve encryption example up and running.